This is an implicit function. We don't have y expressed as some function of x. We've got x's and y's all mixed up. So, to differentiate this, we're just going to do it term by term. We start with this first term, and we observe that it is a product. Now, with a product, we need to take the first term, multiply it by the derivative of the second, and then add the second times the derivative of the first. So, the first term times derivative of the second term, which is just simply dy dx, plus second term times derivative of first term. Then we move on to finding the derivative of this part. Now, we learnt before that that's just 2y dy dx. And finally, the derivative of a constant is simply 0. So, let's tidy that up. We've got an x dy dx here, plus this 2 dy dx here, plus y times 1 is just y, equals 0. Then, factoring this thing is going to give us, in brackets, x plus 2y and dy dx, and then plus y equals 0. Now we can solve that for dy dx quite easily. We subtract y from both sides, so we're going to have this thing minus y equals minus y, and then we can write dy dx equals that negative y over the x plus 2y. So, that's our first derivative. But we need to find the second derivative of this thing, so away we go again. We notice that this is a fraction, and we recall that to find the derivative of a fraction, we take bottom times the derivative of top minus top times derivative of bottom all over bottom squared. So, we write d2y dx squared equals, so it was bottom times derivative of top, so that's going to be negative dy dx, then minus top times derivative of bottom. So derivative of bottom is going to be 1, because the derivative of x is 1, plus 2 dy dx. Then, all over the bottom squared, so we just write x plus 2y squared. Now, this thing can be tidied up somewhat. We can write let's set up our fraction, and we put this on the bottom. And expanding out this thing, we're going to have negative x dy dx, and then expanding out the second term, plus, will actually be minus 2y dy dx again, and then moving on to this part, it's going to be plus y to this bit with this, it's going to be plus 2y dy dx. Now, what we notice is this minus 2y dy dx and this plus 2y dy dx are just going to cancel each other off. So what we can write is that's gone and that's gone. And that is our answer. Now in Scientific Notebook, to make that a little tidier, what we can do is we can put this into a display. This up here is the display button, and put this inside and put this inside, so that everything lines up nicely. And so that's our solution for the second derivative of our implicit function.